Very pleased to introduce our speaker today, Kristin Aquilino. Kristin got a PhD in population biology from UC Davis in 2011. Her dissertation focused on intertidal ecology and biodiversity at the Bodega Marine Lab. And she began working with the Bodega Marine Lab's captive breeding program for the endangered white abalone. And she's continuing to manage that program with funding from the NOAA, the National Oceanic and Atmospheric Administration. And in addition to that, she's working as co-coordinator of ISOPods, inquiry-based science outreach pods, creating hands-on active learning modules for teaching marine science in K-12 classrooms. She also coordinates science and court with general audience science seminar hosted by the wine bar Gourmet Bay in Bodega Bay. So very happy to introduce Kristin Aquilino. Thank you.
Thanks very much, Pam, for inviting me to this. Can everyone hear me okay? I can hear myself very well, so am I too loud?
No.
Okay. I'm really excited to be here today talking about the Bodega Marine Lab. How many of you have been to the Bodega Marine Lab? A number of you. Excellent. Did you go like recently? A long time ago? Last year? Cool. So some of you maybe know a little bit about this place. I'm going to tell you today what our history is, why we're here, what are some of the things that we do in terms of education and outreach and our research. So to just kick things off, these are some like really basic stats about the lab, kind of our vitals. We have faculty from UC Davis campus, we have graduate students, we have postdocs, we have undergraduates, we have staff, and then we have lots of visitors every year from the public. So about 12,000 public visitors every year. We have really amazing facilities. We have a great seawater system. We actually have housing, so students and faculty members visiting research can stay right on site when they're doing research there. And we've collected lots of environmental data dating back to the 1920s, so a long history on Bodega Head. And most of you probably have never seen Bodega Harbor like this. This is before there was a road around the harbor, before we had jetties. This is in 1938. This was taken by the Army Corps of Engineers. And so this is what Bodega Head looked like when people first started doing research in that area. And in fact, in the 1950s, UC Berkeley started taking classes to Bodega Head to try to do marine science, because this was such a unique location. And this was the first little shack. This is down by Port of Bodega, if you're familiar with Bodega Bay. It's the first little shack they started hosting these classes in. And they used to joke that they had a running seawater system. If you were willing to run to the harbor and get a bucket of water and run back to the lab, then you had your seawater. And occasionally they would put that seawater up in that wine barrel on top and actually gravity feed it through their little laboratory space. This is what their lab space looked like. You can see there's a guy with a pipe in the background. There's a woman sipping her coffee in the foreground. We can't do this in our labs these days anymore, but you could then. So these are Berkeley students coming to Bodega Head to get kind of an immersive experience in marine ecology. And this is more what we look like now. So we're in Bodega Bay, on Bodega Head. The lab is currently run by UC Davis, but it wasn't always. So initially, in the top left here, UC Berkeley first established the Bodega Marine Lab in the 1960s. Then they built a building, started bringing their classes there, had visiting scientists, but also some resident researchers there. And then in the 70s, UC Davis was really interested in aquaculture. And of all species, they're interested in the aquaculture of the North American lobster, which is not from here. Where's the North American lobster from? Maine. It's from the East Coast. But we thought, well, we make a bunch of money this way. Aquaculture was really big in the 70s. And there were two problems with farming these species. One is it took a really long time for them to get to market size. Two, they all had to be housed separately in their own little apartments. Because lobsters fight. And you don't want to get a fancy lobster dinner and have one really big claw and one really tiny claw and send it back, right? So it wasn't economically sustainable to farm the species. But interestingly enough, there were scientists at UC Davis at the same time who were really interested in the process of molting. So in order to grow, a crustacean has to molt its exoskeleton and then kind of back out of it and grow a new exoskeleton. And so he started kind of doing a lot of research in this facility. More UC Davis researchers got involved. And eventually, in the early 80s, UC Davis took over this facility from UC Berkeley and built our newest wing called the West Wing. And this is really in a unique location, which is why UC Berkeley initially wanted to establish a marine lab here. So right now we have about 362 acres on our reserve. It's a fairly small reserve. It's part of the UC Natural Reserve System, which is a network of about 40 reserves all around the state, open to UC researchers, but also researchers from other institutions, to students, and to the general public who want to utilize those reserves. They're a really neat network. And even though we have a relatively small reserve, we're the highest used in that whole system. We are also surrounded by protected areas. So even though the reserve is small and only extends about 1,000 meters offshore, we have the state protected area around us. So these state marine protected areas were established recently and go out to 3 miles offshore, which is really neat to be around this really pristine area. And if we go back even further, we're surrounded by a lot of national marine sanctuaries. We have the Cordell Bank National Marine Sanctuary, and there's a proposed expansion of that sanctuary north. So we're in this really unique protected area. And Cordell Bank has an interesting story, an interesting natural history. It's a place where we used to fish a lot of rockfish. And scientists in the 70s got a little bit concerned about how many rockfish we were taking from this area. This is what it looks like now. It's a really beautiful habitat, and it's an amazing nursery for rockfish. But in the 70s, it was decimated by bottom trawling, so scraping the bottom. There was none of this coral there. It was just rock, and no place for these little tiny juvenile fish to hide. So this is a really neat success story. This Cordell Bank National Marine Sanctuary was established, and it's a really happy conservation story. We don't often get to tell those stories, right? We're really trying to save things that we feel like are really degraded. This is a habitat that was really degraded. We protected it, and now it's thriving again. And it's right offshore of Bodega Bay. The other neat thing about where we are is we're in one of only 4 upwelling areas in the world. So upwelling areas occur on the western edges of continents, and they're really productive areas. So they represent only about 1% of the total area of the ocean, but we take about 20% of our fish from that area. So we're really, really productive. So what is upwelling? We've been to Bodega Bay in the spring. Anyone been to the coast in the spring? What's the weather like?
Windy.
It's windy. It's miserable. That wind is exactly what causes this high productivity. So we get winds that come from the north, they blow south. That's what we call Bodega Bay in the springtime. They blow south, and because of the way the earth rotates, the surface water of the ocean actually gets pushed offshore. And something needs to replace that. So really cold, nutrient-rich water from deep in the ocean comes up, we call it upwelling, and replaces that warm surface water that has less nutrients. That process is what drives our salmon fishery, is what drives our Dungeness crab fishery. It really drives the productivity on this coast. It's really, really special, and we're right in the middle of that. So, Bodega Marine Lab, I've kind of touched on, we're in this really unique location. We're on this nice reserve system, we're adjacent to these state and national protected areas, and we're in one of only 4 of these really important coastal upwelling systems in the entire world. But to juxtapose that, we're also very close to San Francisco Bay, which is one of the most impacted estuaries in the world. And a lot of times, like in the winter, we get water that comes up from San Francisco Bay, that comes up all the way up north to this area here. And so this really drives the focus of research at BML, Bodega Marine Lab. So we focus on ocean processes in this highly biodiverse region, but we also focus on the environmental impacts from human activities. And we're able to understand those environmental impacts better because we are in this really pristine area. And in order to understand a lot of those, we have a lot of monitoring. We have lots of buoys around. So we have a buoy at Bodega Marine Lab about 1,000 meters offshore, about a kilometer offshore. We have a buoy at Cordell Bank, the smallest bay. We have a really neat research vessel called the RV Muscle Point. And it was first developed kind of after 9/11, during a lot of Homeland Security push. It's called a safe boat. And this is one of their prototypes for Homeland Security. They sold it to Bodega Marine Lab, and it can self-right. So if all the hatches are closed and everything, and flips over in really high seas, it will flip back over, which is pretty nice. Because a lot of times when we're doing research, we can't wait until a nice sunny day that's calm for it to go out in rough conditions. We have some high-frequency radar that maps surface currents, and it's part of a network all up and down the coast. And lots of shore-based stations that look at things like plate tectonic movements. So we are right on the San Andreas Fault on Bodega Head, so that's an interesting place to be. And I don't know if some of you know the story about PG&E trying to develop a nuclear power plant there in the 60s. Luckily, we don't have that right now because we are right on the fault line. But we're still measuring those technologies. So like I said, this unique location, this history of environmental data, really drives a lot of our research focus. kind of compartmentalize what our research is into 6 main areas: ecology and evolution, coastal oceanography, ocean health, physiology, climate change, and conservation. And we have national funders such as the National Science Foundation, the National Oceanic and Atmospheric Administration, which I work for, Environmental Protection Agency. We are funded by the state through agencies like California Department of Fish and Wildlife, and local agencies like Sonoma County Water Agency and the Delta Science Program. They're kind of our big funders. And I want to spend a little bit of time talking about actual research that we do, because we do some really, really cool things. So the first thing up here is impacts of ocean acidification on marine ecosystems and aquaculture. Who here has heard of ocean acidification? A few of you. Who's heard of climate change? Hopefully most of you. So ocean acidification is a type of climate change. We're pumping CO2 into the atmosphere, and that CO2 needs to go somewhere. Our ocean is like a giant sponge, and it sucks up that CO2. And that actually changes the chemistry of the ocean. So when the CO2 enters the ocean, it makes the ocean more acidic. It creates something called carbonic acid. And that's really a problem for any animal that makes a shell. So crab, oyster, and abalone, things like that. Especially when they're really, really young, they have trouble building that shell in high acidity. And this, the chemical reaction that happens reduces the amount of calcium carbonate in the water. And they need calcium carbonate to make their shell. So this could be a really big problem, not just for kind of the animals that we think are cute or think are important for the ecosystem, but also for our economy here, right? Oyster farming is really, really important on this coast, and we've actually already seen impacts of ocean acidification on oyster farms here and up in Washington and other areas. So this is an area of really active research, which we're trying to figure out which species are going to be most impacted by ocean acidification, if there are things that we can do to mediate ocean acidification and things like that. And interestingly enough, this upwelling that I talked about a minute ago naturally brings acidic water to our coasts. So we're in the middle of this really big upwelling zone, and we're naturally experiencing higher acidity. And that gives us actually a really unique opportunity to study what the general acidity of the ocean will be in the future based on conditions happening in Bodega Bay right now. It also is a unique opportunity to study animals that maybe already have some adaptations to deal with things like acidification. So maybe our oysters here that we're farming, maybe they're already better at dealing with this. Maybe we can use some of their genetics, maybe we can use some of those animals to farm oysters elsewhere as CO2 increases in other parts of the world. But that's one big area. We also do a lot of tracking of things like tsunamis and oil spills. So I mentioned that high frequency radar that we have. The tsunami that hit Fukushima a few years ago, we were able to actually track that using our high frequency radar. And normally, NOAA, the National Oceanic and Atmospheric Administration, tracks tsunamis using these moorings and buoys. So they find out, okay, if the ocean is rising, the tsunami is coming, we better, run right now because it's pretty much here. These high frequency radars, though, go 300 miles offshore. They're really far offshore. And so you're able to see something that's happening even sooner. And when the Fukushima tsunami wave hit this area, it wasn't a very big wave, but we were able to look back at our data and see that we saw a signal in our high-frequency radar of the tsunami coming. And the signal gave us an hour sooner warning for places like San Francisco Bay than these buoys and these moorings did before. And that's a really big deal. That's a much, much more time. That's maybe the difference between packing up what you need to pack up and just forgetting it and running, right? And so there's a whole network already of this high-frequency radar up and down the coast, and we are able now to try to figure out ways that maybe we can have alarms or warning systems, even when we don't necessarily anticipate a tsunami coming, so we know what's happening. The other thing we can do with this radar is track oil spills. So when the Costco Busan hit the Bay Bridge, and we had all this oil spill into San Francisco Bay, we were able to predict, just looking at ocean currents, where that oil was going to go. We were able to predict, for example, that it was going to come north and maybe even hit places like Smalls Bay. And that was really important to know for oyster farmers, for aquaculture, and just for being able to know where to concentrate our spill response teams. We also work with people in the Gulf of Mexico. When we had the Deepwater Horizon spill there, that was kind of a whole new thing in oil spills. All of our previous oil spills have pretty much happened at the surface, or really big spills happen at the surface. So what happens when it occurs in really, really deep water? We have people working on that. The captive restock program for recovery of the critically endangered white abalone is what I work on. So this is a white abalone here. White abalone were the first marine invertebrates to be federally listed as endangered in 2001 because we fished too many of them. And because they're really delicious. Has anyone eaten white abalone? I'm always curious. It's okay. You've eaten white abalone?
Yeah, as a child.
Do you remember it tasting any better?
It was wonderful.
So I hear that they're the most tender of all abalone species. I definitely dove for red abalone, and I've eaten my fair share of red abalone. But yeah, your white abalone were targeted because apparently you didn't even count them, which I think is a little bit of a war. I think you probably
This was
still count
back
them.
in the 50s.
Okay.
So I don't think we even had thought about that.
Definitely not. I mean, it wasn't really until the 70s. I mean, probably peak fishing for most abalone in the 60s and 70s, and it wasn't until the late 70s that we started to realize that some of our abalone species were declining. And part of the problem was we weren't keeping track of individual abalone species. So an abalone was an abalone. So we didn't realize that we were sequentially fishing the different species. Total catches stayed the same, but we pretty much fished all the reds. So we started fishing pinks and greens, and we fished all those. We started fishing the whites, but we didn't see that in our data because fishing wildlife was only collecting a total number. Right now, there's probably only a few thousand white abalone left in the wild, and so we have a captive breeding program at the Bodega Marine Lab to try to make little babies, reintroduce them into the wild, and save the wild population.
What's their mature size?
It's more based on age for white abalone, and they tend to be reproductive in just a year, which is unusual for abalone species. It's one of the only things that white abalone seem to do well. It's very much a challenge to try to breed them in captivity. And so we're really, lucky in that aspect. They don't produce that many young, when they're a year old. When they're about a year, they're about an inch or so long. And they're compared to an animal that's this big, they're not going to produce much. An adult white abalone probably gets to be about 8 inches most.
So I may have taken one without even realizing it?
No. Well, have you dove in Southern California?
No.
Then-
Well, yeah, I mean, but yeah, just out of the channel.
So you probably haven't. White abalone are so rare. Historically, they only range from Point Conception down to Baja.
Oh, okay.
And they're the deepest of all abalone species in California or on this coast. So they're mostly below 100 feet, historically mostly below 60 or 70 feet. The remnant population is pretty much only on offshore banks, mostly below 120 feet. And we have trouble finding them in submersible vehicles. So you probably haven't taken one. And they have white feet, so unlike a red abalone, they have really black feet. If you had taken a white abalone, you'd think it was an albino or something like that, but it was very different. Yeah. It would be really hard. I mean, right now, the recreational fishery for abalone is only in Northern California, north of the Golden Gate. It would be really hard to take anything other than a red abalone, because we have 3 other species in this area. We have black abalone, which are intertidal, very rare, and they're also endangered. We have pinto abalone, those are mostly below 60 feet, which are hard to dive to. And we have flat abalone that don't get much bigger than this.
So I see greens now.
Green's mostly not in Northern California.
Really?
Yeah, mostly in Southern California. You might be seeing pinto abalone. Yeah. Yeah, I don't think greens come quite this far north. Oh, other questions about abalone? It's great. I love talking about it. Delicious. All right, so a couple more things. We look at invasive species impacts on ecosystems, and then we do a lot of graduate training to translate science into local schools, state resource management, and national policy. So a lot of our graduate students go on to go to DC to influence national policy. A lot of them work in Sacramento. A lot of them go and do faculty jobs, like the traditional graduate school track is, and then a lot of them are doing work in local schools. So that's what I want to focus on a little bit right now. We have a really, really exciting new program called Isopods. I'm going to start with, if anyone has heard of the Cameos program. So you have kids that go to Annalee, or anyone who goes to Annalee. So we started this about 5 years ago, this program called Cameos. I have no idea what the acronym stands for. This program that was funded through NSF. It was a K through 12 initiative. And they basically gave graduate students stipends of $30,000 a year to translate their science into local schools in Sonoma and Marin counties. It was incredibly successful. It was amazing. Because not only did the graduate students get to learn how to speak about their science to the general public, because talking to kids about science is not that different often than talking to adults about science or anybody. You have to change your language. It also gave the kids an opportunity to interact with real scientists. And the kids got to see what real scientists do. You know, real scientists aren't just like, you know, Bill Nye, old white guys and white lab coats, right? Some of them are young women, some of them are not white, all of these things. And it was really, really important for Sonoma County and Marin County schools for these kids to interact with scientists. Unfortunately, that program ended, so there is no more funding for that program. And we would really like to keep something like that going. So we already have these great interactions with schools in Sonoma and Marin County, and so we don't want that to end. And we have these graduate students who are trained and ready to go, boots on the ground, implementing their science in schools. So we've started this new program called ISOPODs, which stands for Inquiry-Based Science Outreach Pods. The phrase in science education, and pretty much all education these days, is to do hands-on things. Get the students to learn things kind of on their own organically, rather than the top-down approach of saying, these are the facts, now go memorize them. And we are going to implement those in K-12 classrooms starting this fall. We are kind of in the, I guess, the pilot year of this. We had our first meeting with teachers yesterday. And our new first pod is going to be based on abalone, surveys of abalone that Fish and Wildlife do on this coast. So the students will get little populations of abalone shells. And the shells are different sizes. Some of them are really small, some of them are really large. And they have to make inferences on what the health of the abalone population is based on these shells that they get. So they really have to kind of collect their own data, do their own thinking, and all the things that they will be doing are going to be tied directly to research that's currently going on at the Bodega Marine Lab. So they'll be able to see real data on abalone abundances in Sonoma County and make inferences based on those, and then learn later what the scientists actually did with those data. So really excited about this program. It's in its pilot year, hoping to get some funding for that through NSF and other avenues. So that's one of the things going on. We also just have general visits to the lab. So, like I said, we host over 12,000 visitors every year, school groups. We have docent lab tours 2 to 4 every Friday. That's probably how many of you have seen the lab. But we also do groups of larger groups, kind of more directed tours at other times. So I will say that before I wrap up, I've got a couple more slides, but if any of you are interested in visiting the lab at all, I highly recommend you let me know. I'm happy to coordinate a tour for your group that may be a little bit more extensive than what you can get just when you go see the docents. The other thing that we have coming up, though, is an open house. So on September 13th, from 1 to 5, basically all the labs at the Bodega Marine Lab come out. They have experiments to show you. They have little demonstrations. You get to hold critters, things like that, for adults and kids alike. So I think it's going to be a really, really fun event. We have thousands of people come through during these open houses. So if you are available that weekend, you should definitely check it out. And I just want to finish with some undergraduate education. So UC Davis, its primary goal is to educate undergraduates. And we have really, really great opportunities for them at the Bodega Marine Lab. So we offer in-residence courses. It's almost like they're studying abroad. They can stay in housing at Bodega Marine Lab, and we're remote enough that they don't really get to interact with the rest of the world while they're there. But we offer classes in ecology, population biology, environmental stress, toxicology, physiology and development, and coastal and biological oceanography. And these are really amazing immersive classes. Generally, our student-professor ratio is about 8 to 3. So we have our classes maybe have 8 students in them, maybe fewer. Usually a few professors are teaching those classes. And in addition to that, there's a couple of graduate student TAs, and everyone at the lab is available to them. They do their independent projects based on things that they're interested in. They come up with their own experiments, they conduct their own experiments, and they present them at the end of the quarter to the lab. So they're really almost doing graduate level work during this time at the lab. It's really, really amazing. And I think it's one of the most incredible undergraduate experiences that someone could have. It's something I wish that was available to me when I was an undergraduate. And combined with that, UC Davis has a new Coastal Marine Sciences Institute. I'm just going to read this quote by our founding director, Rick Grossberg. With its focus on humans and coastal oceans, our new Coastal and Marine Sciences Institute assembles a globally recognized experts from more than 20 academic units on the main campus and Bodega Marine Laboratory into one of the most comprehensive and collaborative marine science policy and educational programs in the world. So when you guys think of UC Davis, you probably don't think, oh, marine science. Maybe you think of UC San Diego or UC Santa Cruz. We actually have more faculty at UC Davis doing coastal and marine science than any other UC. And the difference is that we don't have a department right now that brings all those faculty together. So this new institute will do that. It's interdepartmental and actually has the very first undergraduate major that will be interdepartmental in the country. We were really interested in interdisciplinary approaches to education right now, and this one is really at the forefront of that. So that's kind of my spiel about the Bodega Marine Lab. Like I said, I'd love to show you all around the lab. I wish you were there right now, and I wish I could hand you all sea stars and urchins and abalone to hold. So that's way more fun than just talking at you. But I'd love to take any questions that you have about the lab or any research that we do there. Okay.
So you tried to cultivate lobster, is that right?
Yes.
Is there any reason that lobster wouldn't grow naturally introduced to the oceans here?
Not necessarily. So I do know stories about people going to the tides and buying all the lobster and then just releasing them in the harbor. It's a pretty bad idea. Maybe you're helping out those few lobsters, but they could introduce diseases who are done in this crab fishery, all sorts of things that would be really, really detrimental. So as far as I know, none of those lobsters have taken off, so there must be something that's keeping them from being able to be successful in this kind of habitat. Because people do that all over. Someone, I think a year or two ago, found a giant named lobster at the Gulf of Farallones when he was crab fishing. So they are around. People do release them. But yeah, I don't think so far they've been able to establish themselves.
Two questions. One, I fish off that coast a lot. We fish, the whistle buoy, the whistle buoy is sort of directly west from the harbor, and then there's a buoy called Jingle Bells, which I think is out directly in front of the lab.
Okay.
Maybe a little bit more towards Salmon Creek. And I'm also a little bit confused about the sanctuaries there and the protected areas. You suggested that there were overlapping protected areas. Maybe you could explain a little bit how that works.
Sure. So right now the sanctuaries are places you can fish. The main point of the sanctuaries, for the most part, the main point of the sanctuaries is probably actually to disallow any sort of oil drilling in those areas. So most of the areas that are national sanctuaries are fishable. The state protected areas though are not. So there's Bodega Head State Marine Reserve, and that's a no-take area. So that's just off of the Marine Lab, and that goes out 3 miles.
It goes out 3 miles.
Yeah.
Directly off.
Directly in front of Bodega Head.
And how wide is it?
I guess I don't know quite how far north it goes. There's definitely an area south of Bodega Head that you can salmon fish in. I think that's just crab fishing. So there's really nice maps online. So as opposed to taking my word for it.
There's guys that are trolling back and forth across that
We
area.
definitely see that. It's less so now than it was a few years ago when those protected areas were first established. We call Fish and Wildlife whenever we see those kinds of things. But yeah, I would say definitely go to the Fish and Wildlife website. They have really nice maps right now that delineate the different kind of areas that are going to take. And most new GPS units that you take out in your boat have all of those new maps overlaid on them.
I do have one other question, and this is, I've been out fishing over the last couple months, and a couple of weeks ago, the water was like 63 degrees, like a mile off the coast, just freakishly warm. And what is the explanation for that, and what is its impact on salmon fishery? Because the salmon, now you only can catch them right on the bottom, and I assume that that's because the water temperature goes, I don't know yet.
So that's a great question. So the first thing I heard over here was El Nino. It is predicted to be a very strong El Nino year, but this warm water is not from El Nino quite yet. That would be coming up a little bit later. This is partly from the lack of upwelling I talked about earlier. So we've had very little wind for months, and so that surface water is able to get warmer and warmer. We've also had a lot of weather from the south, so we've had a lot of winds from the south, and that brings warmer water. So that kind of combination of things is probably what was making the surface water so much warmer. It's the warmest that some people have ever seen in Bodega Bay in the past 20 years. So it's incredibly warm. And it's bringing strange species and things like that. Sunfish, so part of that reason is bringing lots of jellies. And so the mole are following the jellies. So we get this by-the-wind sailor that has blue bottom and a little sail on top. You can see a lot of those washing up on shore and other kind of jellies. So the sunfish are following those. So that's kind of happening. How that affects the salmon, I don't know a lot about that in particular, but I'm sure it's affecting a lot of the fish species out there.
So there's been a lot of discussion about climate change impacting ocean currents. Could that potentially be affecting the upwelling? And are you anticipating any, what changes are you anticipating to do with
huge question. So the question is what changes are we anticipating due to climate change on the coast? The most immediate thing is this ocean acidification, because it is happening now and it is so strong. So I think that that's happening now versus things like increase in temperature, generally increase in storms, changes in currents and things like that. Those things will probably happen if we continue business as usual, but that might be a little bit further down the road. I don't study those things specifically. We actually have, Jessica knows about this, one of the things I'm involved in is called Science Uncorked. We do a little science talk at the Weinberg Romeo Bay on Tuesday nights. And our next speaker, who's next week, Matt Robart, he studies ocean currents and might be able to answer that question better than I could. Yes.
During the tsunami, do you know to what elevation the water may rise?
During any hypothetical tsunami, what elevation might the water rise?
Yeah, like the worst case.
I don't know the answer to that. It could be, I mean, yeah, I have no idea. It could get pretty high. I mean, we mostly, it's gonna like a flea wash over Bodega Head. I don't know. That's a good question. Tsunami waves are so interesting because so much of their impact is kind of, the wave is so broad. So a lot of our impacts are in places like bays and harbors and estuaries because you just have a lot of water come in. You don't necessarily have one big wave. But yeah, I don't know. I could find out and get back to you. Some of our ocean markers. Yeah.
I think there are maps, county has maps, geologic maps that indicate where the line is for the case.
We definitely have those kind of tsunami evacuation zones and things like that in our Provo and areas. Yeah.
Kristin, thank you very much for the most fascinating.
Very welcome.
I have a little task for you.
Oh,
We have a door prize.
okay.
And if you would draw one of these tickets and then read the last 4 digits.
0989. Ha!
I would like to thank you for making a contribution to the anti-polio now. And thank you very much for Okay. There's the ticket. Here's the card. There's the money. Okay, so let's see if there's an ace in here. These are all diamonds.
Can't look at his glasses.
So, hopefully nothing is visible. Oh, that's all right, so, give me a pro second. Ron Cutter, Jake,
Are we good? Good. I forgot to get jokes. I got this from Frank this morning. Okay, this gentleman goes to visit his father in a senior care facility, and so he sits down and they're talking, and he goes, "Dad, can I get you anything? Can I get you some gum or anything like that? Is there anything you need?" And he starts to lean over a little bit. His hand comes off from behind and pulls him back up. So they're talking away. And "Are you sure there's nothing I can get you? Some donuts or anything you want?" So he starts to lean over a little bit. Caretaker on behind reaches over, pulls him back up again. "Now you're really happy. You sure you're really happy? There's nothing I mean, is there anything going on here? Anything I can help you with? I mean, staff or anything?" And he goes, "Well, there is this one little slight problem." And he starts to lean over and he goes, "They won't let me fart."
Okay, Frank.
Oh, the caption contest. Well, we had 2 entries, and both of them named Bruce Campbell as the best dressed with the glasses. So, there's no winner this week, but it was a lot of fun. We probably should fine Linda Sinkay $5 for she did. Because we didn't get the caption photos to do the caption because she had a birthday last week and she went away and had a wonderful time.
Just too busy.
So, that was $5. Okay.